We did learn about what are the requirements for combustion to take place. We did learn about that also. Okay. Why some activity we did learn that. Okay. We did learn about types of combustion also. There are namely three types of combustion. That is rapid combustion, spontaneous combustion, and explosive combustion. You tell me out of the three type of combustion which we have learned previously, which one of them would be taking place on its own? It will not require a external means of heat.
Can you repeat the question, sir? I have some network issue.
Okay. Out of the three type of combustion we have studied about, which one of them does not require an external heat, external source of heat? Yes. Is it rapid combustion? Is it spontaneous combustion or explosive combustion?
Explosive combustion.
Not explosive combustion? No. How can it be explosive combustion? Like whenever someone burns the firecracker, so they have to light it using a matchstick or something, no? Yes.
Yes.
So an external source of heat is provided there now. So that is not one such example. Okay. So I had given you some examples like the example
Good
of,
evening, sir.
yeah, good evening, Vaika. How are you? So
Good, sir.
so we had learned about examples of spontaneous combustion like the coal gas. The miners that would be working in the mine, sometimes due to if the internal temperature in the coal mine is very high, the coal gas can it can spontaneously catch fire on its own. Or you have the example of yellow phosphorus or white phosphorus. If it were to be left in open, it will automatically catch fire. Okay. Vaika, you were also absent in the previous class. Aisha was only present, and there we did learn about the history of matchstick and what type of chemicals were earlier used in a matchstick, and nowadays what type of chemical is used in this, and what is
Okay,
the
sir.
principle of working of this matchstick. Okay. Okay. Since both of you are present, I will be just back in a minute. Let me take the charger of the iPad. Otherwise, it would be turning off in a minute, in a few minutes. Okay. Also, meanwhile, you guys do one thing. Both of you, um, Read this given paragraph. Not necessarily allowed. Just read the given paragraph. I will be back in a minute. Let me take the charger. Okay. Yeah, I'm back. Okay. I suppose you guys have read the given paragraph. Yeah. What did you understood from this paragraph, Vaiga? You done?
No, sir, I'm not done yet.
Okay. Okay. Read it. Yes, Ibrahim.
Yes, sir. Done.
Then, so the history of matchstick, how old is it? Yes, how old is the history of
It's
matchsticks?
more than 5,000.
More than 5,000.
Good. So earlier, what kind of chemicals were used in matchstick? What kind of chemicals, what kind of substances were being used on the head of this woody stem? The head of this woody stem that was used making what kind of chemicals? Earlier, we had chemicals like antimony trisulfide used in it. This is used nowadays also. It is used. It has not been replaced. Okay, no. Trisulfide. This was used. Apart from this, there were chemicals like white phosphorus being used into this, potassium chlorate also. So potassium chlorate, and there was one more, that is white phosphorus. So how you'd be mixing all these chemicals? All of them are dry now. Dry powders, they would be in a state of powder. How you'd be mixing them? How do you pasting it on the top of the woody stem? Yes, Figer, by using some glue, right now.
Yes,
So
sir.
apart
Yes, sir.
from all this, glue and starch were also used. Glue and starch were also used to prepare a paste of it, and that paste was basically put on the top of this wood stem. Okay. Now, once this was struck against a hard surface, like against the surface of a rock or some other hard surface, so what would happen due to friction? Due to friction, this white phosphorus would ignite. This white phosphorus, it is highly unstable, it is highly reactive and unstable chemical. It's a very unstable. It would be reacting vigorously with air, with particularly with oxygen. Getting it? So the principle was that the working principle of a matchstick is that once you strike it against a hard surface, due to friction, heat will be generated. Right now, so friction will generate heat, and that heat will be sufficient for this white phosphorus to ignite, to catch fire. So due to heat, the white phosphorus would ignite. It will ignite, and as it will ignite, the other chemicals will also ignite, and it will raise the ignition temperature of the wood also. Right now, so sufficient amount of heat will be generated that will make the wood to burn. That is how it used to work. But that time the matchsticks were not very safe. Okay, na? Because in that we were using this white phosphorus, and which was a very unstable compound, highly reactive chemical.
Yes, sir.
Okay, so it was not very safe. So thereby, in order to make it less dangerous, nowadays that white phosphorus has been replaced with red phosphorus. All the other chemicals in this have been same, just the white phosphorus nowadays has been replaced with the pink phosphorus, right? Or the red phosphorus, or the yellow phosphorus. Yeah, the white phosphorus has been replaced with which one?
Red phosphorus.
Red phosphorus. Very good, Aisha. Because it is much safer. Okay. Also nowadays, instead of rubbing it on a rough surface like rock or something else, we have a matchbox, the surface of which is made using some powdered glass, and some other chemicals are also put into this. So once you would be rubbing this matchstick against its surface, first the red phosphorus would be igniting. Right now, the red phosphorus would be igniting, right? And this red phosphorus would convert into white phosphorus. Some of the red phosphorus would convert into white phosphorus. They were further, we know that white phosphorus is much more combustible. It will generate much more amount of heat. So thereby, once it would be rubbed against the surface of the matchbox, due to friction, heat is generated, and that heat will be sufficient for this red phosphorus to ignite. Okay. And here in the paragraph also I have written that upon burning, the main component of the matchstick that we use nowadays, by the way, the matchsticks that we use nowadays are also called as safety matchsticks. Safety matchsticks because it does not cause harm to the person who is burning it. Although the gases that are released upon burning of matchstick, one should avoid inhaling it. Have you guys observed this? If accidentally, if you were to inhale this gas, it will be kind of problematic. You will feel uncomfortable. Yes, did that ever happen to any one of you? Further, the red phosphorus would be burning, and some of the red phosphorus will turn into white phosphorus upon heating. And white phosphorus, we know, in the case of spontaneous combustion, I did told you that white phosphorus would go under spontaneous combustion. It is erased over here, but I did told you about that one also, that it spontaneously catches fire right now. So it would go under spontaneous combustion, and thereby now the temperature of the wood would be increased further. So the wood will also catch fire. Also, we did learn this question that by using a piece of matchstick, you will won't be able to burn a piece of wood, but you would be able to burn a piece of paper, but not wood, because one matchstick will not produce sufficient amount of temperature to burn a piece of wood. Thereby, you have to use papers, straw, and other materials to burn wood. Which of the following is used in matchstick? Waited this question, Aisha. You guys also answer this in the class only. Yeah, Ibrahim, what is the answer to this question? Viger and Aisha, you two can answer.
Carbon,
Red phosphorus.
not
Red
carbon, the red
phosphorus.
phosphorus.
Red phosphorus, very good. Okay. And this activity we have done in the previous class. Let me just quickly recall this concept. The concept basically says that you guys know about the ignition temperature already. That is the minimum temperature required for any substance to catch fire. It's the lowest temperature right now, and it varies from one substance to another. It will vary from one substance to another, and the ignition temperature will depend upon different things. Like it will depend upon the different types of fuels, whether it's a solid fuel, liquid fuel, or gaseous fuels. Usually, you guys tell me which fuel would be having a lower ignition temperature. Will it be a solid fuel, liquid, or gaseous fuel? In a general sense, I'm asking this question. Yes,
Gaseous fuel.
of course, gaseous fuel, no? Right? Okay, so it would be varying depending upon the state of the fuel, depending upon the carbon content or hydrocarbons found in the fuel, it would be varying. But the general thing we have learned that it's the minimum temperature required for any fuel to catch fire, any combustible substance to catch fire. Okay, here in this activity, we had taken two filter papers. We had made cones of those papers, and in one of them, water has been put, another one is empty. The first one would not be catching fire unless all the water evaporates. Right. So in the beginning, why it will not catch fire while the other one catches fire? Why this one hasn't caught fire? The reason being is
What
yeah,
water
continue.
absorbs the
Exactly. Water absorbs the heat, thereby it will start to boil and then convert into water vapor. So once all the water have evaporated and converted into water vapor, then the paper will now catch fire. So it because at that time, till the water were present in it, the ignition temperature of the paper was lowered due to presence of water. Once there was no water, immediately it will catch fire as the ignition temperature was reached. So that is one thing which we learned. We did learn about fire and how do we control the fire. You guys were also previous while we were discussing this topic. Okay, now, and this topic, why during an incident of fire one has to be covered with a blanket, because that will simply cut off the contact of oxygen of generally fire, generally air. Okay, we did learn about different types of fire extinguisher. Yes, Aisha, we did learn about this now.
Yes, sir.
Okay. Ibrahim and Vaiga, did you guys watch the recording of the previous class? Please let me know.
No, sir.
No.
yes, sir.
Okay, you have Ibrahim. Good. See, I'm just going to quickly go through these topics because it's a lengthy topic and it would be taking a significant amount of time to revise this again. So, if Viga, please do one thing now. If possible, please watch the recording. So, I'm just going to give an brief overview of the topics. Okay, now we have fun. So, about the carbon dioxide extinguisher and the water, you guys already know about this. But there are some other kind of fire extinguishers also, like the powder fire extinguisher and the foam fire extinguisher. So what interesting things which we learned in the previous class is that there's a soda acid fire extinguisher. Soda acid fire extinguisher. We'll be learning about that, but let's first learn about dry powder fire extinguisher. Okay, now see, the basic thing is that this fire extinguisher, it is using carbon dioxide. This one will also be using carbon dioxide. Okay, now there's something special about the foam fire extinguisher. It would be using foam and carbon dioxide both. Let me write that down. Carbon dioxide used, of course, it is mentioned in the fire extinguisher as well. Here, carbon dioxide along with this foam will also be reduced when we use such kind of fire extinguisher. Okay. Here also carbon dioxide gas is produced. This is the only one in which water is only used to extinguish the fire. So we are going to learn about these three. Okay. All right now. So first of all, let us learn about the powder carbon dioxide fire extinguisher. Okay. So powder or dry powder fire extinguisher. So in this type of fire extinguisher, it would generally contain a mixture of baking soda and sand. You have baking soda, that is this, and you'd be taking sand. So like this, these are, let us say, baking soda, and you have sand particles. Because we know baking soda, once it comes in contact with heat, it will break into its components. This is baking soda, as you can see over in this equation. You can see this, that is baking soda. Also sodium bicarbonate, same thing, that's the chemical name of baking soda. Okay, now so once it is heated, it comes into contact with fire, it will break into sodium bicarbonate, water, and carbon dioxide. Forget about the first two, that is really not important for you to remember as of now. Just know that carbon dioxide will be given off. Understood this, Vaiga, Ibrahim, and Aisha?
Yes, sir.
Okay.
Yes,
Also,
sir.
we are not purely using baking soda. We would be preparing a mixture. We would be using sand also, because sand is also helpful in extinguishing a fire. That is the first type. Okay. So right now we are done revising about this type. Okay. Now let us learn about the another type. This one. How this type of fire extinguisher works. Okay. Now, so previously I did told you in some of them carbon dioxide would be stored in the liquid form. Just like liquefied petroleum gas, it is stored in the form of liquid in the LPG cylinders. So in one type of CO2 extinguishers, the carbon dioxide gas would be stored in the liquid form, as we have learned previously. But in older ones now, like if you were to like the ones that are available nowadays, it is of this type, in which carbon dioxide would be stored in the liquid state. But few years ago, another kind of fire extinguishers were used. The principle of using that kind of fire extinguisher was that two kind of substances were used. One that is baking soda, and another one was, yes, Aisha, there was an acid. What was the name of acid?
Sulfuric acid.
Very good. That was sulfuric acid. So when these two would be reacting, a gas would be given off. Can you guess the name of the gas?
Carbon
It's,
dioxide.
of course, carbon dioxide gas is given off. Okay, Vaika. So
Yes, sir.
the setup was in such a manner, like this is a cylindrical structure in which you have this handle, kind of not a handle, but a plunger or kind of a push button. Whenever there's a fire, you have to push this. So once you push this, what happens? In this sealed glass container, a very thin glass container, in this sulfuric acid, a very strong sulfuric acid was put into this. And it was very thin and it was held in its place using a wire. So as you push the plunger, it will be broken off. And this whole structure where I'm pointing, this is filled with baking soda. solution of baking soda, not in the powdered state, but in a soluble state in the form of solution. So thereby, once you break it right now, so thereby the acid will be reacting with this base, and thereby from this wax seal, uh, as lots of carbon dioxide gas will be produced, this will push the wax seal. The wax will be removed, and thereby lots of carbon dioxide will be coming out of it. Another type of the fire extinguisher was foam type fire extinguisher, in which basically a chemical called as saponin or turkey red oil was used. Basically, in this solution now, you would be adding saponin. That's it. You'd be adding saponin to the solution. The setup would be same setup, but a chemical called as saporin, saporin, was used. So at in that case, now along with carbon dioxide, foam will also be given off. Okay, and we know that foam would be lighter than oil. So suppose if the cause of fire is oil, so there you can especially use the foam type fire extinguisher, because as the foam will come out of the fire extinguisher, thereby the foam will float above the oil, and thereby will cut off the supply of oxygen, and hence will be very efficient in putting out oil fires. So hope that was clear to all of you. So from now here,
Yes, sir.
good. Vaika, you understood those things? Please let me know.
Yes, sir.
Very good. So one basic question is that when should we use, or when should we do not, when we should not be using water to extinguish the fire? Answer this question, that when should water be used to extinguish the fire and when it should not? Yeah, come on, answer this question. It's a simple question.
Like when there is like a large fire, we
No,
can't use water.
talking about the material which is on fire, the type
Okay.
of fuel which is on fire. Yes, go on. Should I give you guys options? I
Yes,
think
sir.
you okay. Okay, first type, when you should be using it. Okay, now I'm just going to give the options. You have to tell me in which case you should be using, which case you should not be using. Okay, so it's like, let me just completely write it down. Oil, wood, oil, like cloth, plastics, short circuit,
Sir,
electrical appliances. Yeah, just 1 minute. Electrical
for
appliances on fire. Yeah, now it is completed.
okay. So for oil, we can't use.
Good. That one I will be circling using this color.
And for
And
short
yeah, Aisha.
short circuit,
Short circuit.
Good.
electrical
Good, Ibrahim.
apply.
Good. And all the remaining ones, wood, cloth, and plastic, there you can use it, right? Use the water for extinguishing the fire. Good. Read the next question. The next question is, what should we do when electrical appliances are on fire? What should we do? How should we extinguish the fire when such electrical appliances on fire? What would be the sequence of the steps you are going to follow? Electrical equipment, or if there are some inflammable materials like petrol catches fire. First of all, talking about electrical equipment, the very first thing what you should be doing, think of it logically and answer to me. Yes, anyone?
We will close the we'll close the
Very good. Right now, very logically answered. First of all, you have to disconnect the source of electricity. If it is safe for you to do so, they will simply plug out or switch off the power or at the fuse box. Okay. Next, first of all, of course, you are not going to use water in this right now. Neither
No, sir.
neither sand will be sufficient. Okay, now neither sand will be sufficient. If it's a small fire, it's okay, but it might not be sufficient. Okay, now so thereby what kind of extinguisher you are going to use? Moments ago we
Carbon
have learned to,
dioxide.
exactly, no. So we are going to use a carbon dioxide fire extinguisher. Getting it? Okay, no. So any kind of fire extinguisher you can be using, that is would be giving off carbon dioxide particularly. Okay. Now in the second case, you have inflammable material like petrol is on fire. Now in this case, what you guys are going to do? First of all, eliminate. Can water be used?
No, sir.
No. Then what should be used?
Foam.
Powder extinguishers.
Powdered, yeah, that can be used. But there's one more type of fire extinguisher which we have done will be much more efficient. In this image, you can take the hint. From here, you can take the hint.
Foam.
Exactly. That type of fire extinguisher will be best. Okay, now because carbon dioxide will be given off, okay, but apart from that, foam will float above the oil, thereby cutting off the supply of oxygen. Right now? Okay. So that is one thing. You know. Also, most of the common causes of the fire has been observed to be short circuit or overloading. So thereby, whenever there's installation of circuit in your house, make sure that good quality wires are being used. Okay, now the wires are not tightly compactly jammed. Okay, now the circuit is proper. So all those things should be taken care of. Anyways, okay, answer this question quickly. Which of the
All
following
of
is used to extinguish fire? Exactly, that is all of the
All.
above would be used. Okay, yeah. Answer the first question, Aisha. Yes, you answered the first question. And these two, Ibrahim, and these two, Vaiga. Okay.
Pollution.
List conditions under which combustion can take place.
Okay.
Okay, meanwhile, Ibrahim and Vaiga, if you guys wish, you can also continue to answer.
Sir, for the first one, it's pollution of air, and the second one is LPG.
Good. Aisha, you're required to answer this one, by the way. Yeah.
Presence of combustion substance.
Very good. So that is a fuel is required. Next.
So can I tell mine?
Yeah.
Fuel must be heated to its ignition temperature before it starts burning.
Very good.
Fire produced by oil cannot be controlled by water.
Very good. Yeah, Aisha, continue.
Air.
Air, or more specifically, oxygen. Good. And
Heat.
heat, or specifically ignition temperature. That would be more appropriate to say. Okay, now. Okay, we have got some more questions to do, but we'll be doing that after some time. Okay, now after having learned about some more things, we'd be able to do that. Okay. Now talking about flame, right? So whenever there would be a fuel on fire, so you will see that whenever a fuel would undergo combustion, or not all the fuels would be giving off flame, but there are some fuel that when they go under combustion, they would be converting into the vapor state. They would release some vapors also, release some gases also. Can you guys think of some fuels that would release gases upon burning? Hmm?
Coal.
Coal necessarily does not give that much of gas, not a significant amount of gas. Some fuels will burn with a flame. It will burn with a flame while some will not burn with a flame. Answer in that sense. Like think of the fuels that upon burning will give the flame and some which will not be giving flame. Like in the kitchen, there's a fuel that gives flame. That is for cooking of food or fuel, that is LPG is used and gives a flame. It's already in the gas state, okay? But what about a wax? Like paraffin wax used in the candles. That also gives a flame. The reason being, upon burning the wax of the candle, it first of all melts and it converts into the gaseous state. Getting it what I'm trying to say? The paraffin wax that is used in the candle, upon burning, it converts into wax vapor. Okay, so we have a gaseous state of the fuel, thereby flame is visible in that. Flame is observed. Okay. Also in this case, in the liquefied petroleum gas, the fuel is already in the gaseous state, thereby it is giving you flame. While in the case of fuel like coal, coal does not burns with a flame. Have you seen a burning of a coal? While a coal is burning, does it give off any flame? Yeah, it basically no, it basically glows now. It basically will be glowing. Or we have example of charcoal also. So when they burn, they will not be giving off any flame, right? The reason being is that they are not giving combustible vapors, or they are not giving vapors at all. Okay, na? If it's a moist coal, if it is wet, or the charcoal is wet, that's a different thing. Okay, now I'm talking about a dry coal and charcoal. When it is dry, it does not hold moisture in it. So upon combustion, it will not be converting into the gaseous state. That's why it does not give the flame. So have you guys understood this thing, huh? That why some fuel burns with a flame while some does not burn with a flame. So Aisha, Waika, and Ibrahim, what is the main reason behind that? The main reason would be whether it would be vaporizing upon burning or not. Okay, now whether it converts into the vapor state or not. Right. So we have examples of fuels like candles that produces flames because it vaporizes. Then LPG, it is already in the vapor state. Then fuels in the liquid state like diesel, petrol, or kerosene, they would also be giving flame because upon burning they vaporizes. Is that clear to everyone?
Yes, sir.
Okay, no? And what is this fire? I mean to say, what is this flame? What is flame? I shall read the given paragraph. Yeah, be quick.
Flame is a
Hmm.
visible and gaseous part of the fire. What we see as the flame is the light energy released due to the combustion of oil.
Very good.
Fuel.
Fuel. So when such kind of fuel like paraffin wax or LPG, kerosene, diesel, petrol, they would be burning. They would be, as a result of burning, they would be giving flame. Right now, also we know that combustion gives you light and heat both. Right now, so while these kind of fuels would be burning, they would be giving much amount of light energy. Okay, now, so we have example of paraffin wax, LPG, petrol, diesel, kerosene. One thing common about all of them is that they convert into they basically would be vaporizing. So they vaporize, hence they gives the flame. And flame is basically the visible part of, like the gas is burning there. So upon burning of gas, the flame is produced. Like over here, the gas is burning, and due to the burning of the gas, flame is produced. So it's a result of the burning of the gas specifically. Okay. Also here in this list, you can look at some of the materials that would be forming flame upon burning. Okay, now, like candle, of course, it forms flame, right? Now, magnesium, it does not form a flame upon burning. Camphor, it would be forming flame upon burning, right? Now, kerosene, charcoal, yeah, charcoal, it says that forms flame, but it does not form flame actually. Okay, now kerosene stove would be forming flame. So what do we observe here? That these are some of the examples. Okay, now. So answer this first question in the chat box, both all of you, 1 and 2. By the way, second question I will be explaining in a minute. Okay, now, so answer the first question only. And in a minute, we'll be learning about this, that what will happen when charcoal will be burned in closed room. Hmm. Correct. Aisha and Ibrahim. Vaika, your answer is pending. Yes, Vaika. Talking about the second question.
Yes, I'm actually sending it.
Okay. Talking about the second question, like burning of the charcoal in a closed space, in a closed room, it can be very fatal. It can be very dangerous, right now, because in closed space or in a closed room, there would be lack of air, right now. So in lack of air and limited supply of oxygen, charcoal would be burning incompletely. It will not completely burn. Incomplete combustion will be taking place. So whenever charcoal would be burning in a limited supply of air, it rather than releasing carbon dioxide, it will be releasing carbon monoxide, which is a poisonous gas. And the bad part about the carbon monoxide gas is that it is an odorless gas. It does not have any smell. So you will not be able to detect it. It will go undetected. Okay, na? It will go undetected. And also one more thing, what happens now, as the charcoal would be burning, uh, this burning charcoal, it would be utilizing all the oxygen present in your room. It would be for combustion, oxygen is required now. Although here the charcoal which we have, it has a limited supply of oxygen, but oxygen it has whatever oxygen is there in the room, it would be taken up by this. So let us understand what is happening here. So all this oxygen would be taken up by this. Let us say that this is a closed room and there is no ventilation in this room. It is completely packed. Vaiga, your answer is not correct. Think of it again. No. Moments ago we did learn about this now. What have we learned here? Look at the examples. This one and this one. Huh? We learned that the fuels that would be vaporizing would be giving vapor, but coal or coal and charcoal particularly, they will not be vaporizing and hence will be giving flame. Okay.
Okay, sir.
So here we have a closed room and there is no ventilation in this room. There is no incoming or outgoing of the air in this room. So thereby this burning charcoal would be consuming all the oxygen present in this room, and in the process of doing so, it is going through an incomplete combustion, hence releasing a gas called as carbon monoxide. What are the things about carbon monoxide I have told you?
It's poison.
And one more thing I
It
told
has
you.
no odor.
Very good. So odorless, thereby it will go undetected. You won't be smelling it, hence it goes undetected. Also, another bad part about this carbon monoxide gas is that it has got a higher affinity towards the hemoglobin in your blood. It has got higher attraction towards the hemoglobin in the world multiple times right now. So thereby it will be mixing in your blood, and thereby slowly the person would be dying. The next morning the person would not wake up. So also it might make the person initially, it might make the person suffocate also right now. And if the concentration is too much, then it will lead to death. So the answer for second question would be, obviously it would be, yeah, do I need to answer it now? You guys already know the
Carbon
answer. Yes,
monoxide.
carbon monoxide. Awesome. Good.
Yes, sir.
Good. Now we are going to learn about the structure of a flame. So you all would have looked at a burning candle. You would all have burned candles sometime. So there you would have observed that there would be different zones of a candle. It would be having three different zones. Like you look at the innermost zone that is near to the thread, that would be usually black in color. Then the next zone would be very bright, and this zone would be giving lots of light, right? And that will be called as luminous zone, or that is the middle zone. And the outermost zone is blue in color, right now, and it is least luminant, right now. It is the non-luminous zone of the flame of the candle. So observe here that generally, usually, the color, the majority of the color of this is yellow. Right now, the majority of the color of this flame is yellow, isn't it? What guys? What
Yes,
would you
sir.
say about this burning LPG? Why majority of the flame is blue in color? What is the reason behind that? Yeah, the reason, the basic reason. Can you guys think of it? Hmm? Yes, Aisha, Ibrahim, and Vaika. See, the basic reason behind why you are getting two different types of flame here is because in one of them, complete combustion, almost complete combustion is taking place. Fuel is completely burning. In one of them, fuel is not completely burning. Here in this case, the there are some unburned carbon particles also that is not burning properly, right now. So that is why it is giving a yellow flame. While here, all the fuels, almost 99% of the fuel would have burned completely, thereby it will give you a blue flame. So one basic difference, keep in mind that whenever a fuel would be completely burning, it would be giving a blue flame. And while the fuel is not burning completely, thereby it will give you a, yes, when the fuel does not burns properly, when partial combustion takes place, then what kind of flame it will be giving? Will it be giving you
Yellow.
blue flame or yellow flame? Yellow
Yellow
flame.
flame.
Very good. So the color of the flame indicates the type of combustion the substance is undergoing. Okay, now the kind of combustion they are going on right now. So that is one basic thing. Okay, now also many times now you observe that although this is giving you a blue flame, although this LPG is a clean fuel, but many times you can observe that if the burner is rusted, if it is not proper, so that too will be giving you a yellow flame. And you will find that sometimes now you will observe that a black a carbon black layer would be left on the bottom of the heated objects, like the cooking pan, the bottom of the cooking pan, that will become black because if the burner is not proper, if it is rusted, so thereby due to deposition of the unburned carbon particles on the base of the cooking utensils, it will become black. That is one thing. Furthermore, talking about this blue flame now, this blue flame will be the hottest. Suppose you have to, like for example, have you guys ever seen a goldsmith? You know what a goldsmith, no? What a goldsmith is? Yeah,
Yes, sir.
good. Or say for example, you want to heat something. You have to heat something. So thereby, just 1 minute. Hmm. I was asking, talking about this one. Why the goldsmiths would be for example, in order to melt gold or silver, he would be blowing at the outermost zone of a flame for melting gold and silver. Basically, he will be taking help of the outermost zone of the flame of the candle, that is the blue one. What could have been the reason behind that? Hmm? We'd be learning about that. huh? Furthermore, you would have observed this that once you place a piece of paper above a lighted candle, there would be deposition of this black color on this. Why does that happen? Yeah, Aisha, Vaika, and Ibrahim. You'd have observed this sometime. Sometime you might would have done this. Hmm? So why does
Yes,
that
sir.
happen? Okay. Now, furthermore, there's an interesting activity that if you were to place a glass tube in the innermost zone of a candle flame, like this one that you see over the black zone over here, the dark zone. Okay, now, and on the other end of this, if I were to place a burning matchstick, it will it will burn at a very rapid state. Okay, now it will catch fire rigorously. So why does that happen? So all those things it would be clear once we get to know about the structure of the candle flame. Okay, now okay. Why I read the given paragraph?
Okay, sir. Structure of a flame. A flame consists of three zones or three parts. These are innermost zone, middle zone, and outer zone. The three zones of a flame have different colors and different temperatures.
Good. So all of them would be having different temperatures also apart from having different colors. Okay. So there you will get to know about that why the outermost part was used by the goldsmith. First of all, we're going to talk about the innermost zone of a candle flame. Okay. And why it is black in color. Okay. So Vaiga, Ibrahim, you read the first this paragraph about the innermost zone.
Innermost zone, dark zone. Least hot zone, black in color, contains unburned wax vapor.
Okay. So what is happening in the innermost zone of a candle flame? That we know that first of all, the wax due to heat it will be converted into the wax vapor. It would be vaporizing and will convert into the gaseous state, right? So they were converted into the wax vapor. Okay. Now here, incomplete combustion is taking place. It is not completely burning. The reason being is that it is not getting sufficient access to oxygen, sufficient contact with air. Since it is the in lying in the innermost area, so thereby it does not get sufficient amount of oxygen. So thereby it will not be burning properly. So thereby the wax vapors in this zone, in the innermost zone, have not burnt properly. So it contains the unburnt wax vapors. It would be containing unburnt wax vapors. Got this so far?
Yes, sir.
That's rather simple. And then it would be black in color. It is will be black in color, and since it is not burning properly, hence the temperature would be lowest. Comparing to the middle and the outermost zone, the temperature of this zone is going to be lowest. Okay, I shall read the next paragraph. Middle zone.
Middle zone, luminous zone, moderately hot, yellow in color. Incomplete combustion occurs.
Good. So here this is the basically middle zone because lying between the innermost and the outermost, and it is also being called as luminous zone because the light of the candle is basically coming from this zone of the flame. Okay, luminous you guys know about something that gives out light. So it will be giving sufficient amount of light, good amount of light. Now here also, what will happen? The unburnt wax vapors that were there in the middle zone, in the innermost zone, it has some of the vapors would have risen now. Anything that is hot, it rises up, isn't it, Viger?
Yes,
Right,
sir.
Aisha, Ibrahim. So the unburned wax vapors, it would be rising also. Why it would be remaining at that zone also? It will rise now. So those unburned wax vapors are rising up and their combustion is happening. They are going through combustion, but not 100%. Incompletely, they are burning. They are not completely burning yet. Okay, now getting it. So here, incomplete combustion is taking place. They do not burn completely again because they are not having sufficient access to oxygen. Right? Okay, now so in this partial combustion is taking place. Hope you guys are getting that thing. And this partial combustion is taking place. Okay, and the color would be yellow. In its color is going to be yellow. Furthermore, we get to see that after this, we have the outermost zone. Why can read the first paragraph, this one? By the way, talking about the temperature also, it would be moderately hot. Neither too hot, neither too less in temperature. Basically lying in between the temperature of outermost zone and the innermost zone. Okay, why can read this paragraph?
Okay, sir. Outermost zone, non-luminous zone. Hottest zone, blue in color, complete combustion occurs.
Good. So here the vapors of the candle, it would be having a good access, it would be having a good contact with the air, so thereby it would be completely burning. And whenever complete combustion takes place, maximum amount of energy is given out in the form of heat, right? A maximum amount of energy will be given out, thereby it is the hottest zone, and it is blue in color. So blue means it is hottest, yellow and black means they are comparatively less hot. So that was the structure of a candle flame and the different zones which we have learned here. Hope that is clear to everyone. Now we are going to do some activities. Via some activities, we'll be learning about them in detail. Okay. So far, any confusions?
No, sir.
No, sir.
Okay. So right now we are going to learn about some activities on structure of flame. Okay. So the first activity, what we are going to do here, you have lighted a candle. Now you have taken a glass tube, a hollow glass tube. Both the sides are open. Now, using a pair of tongs, a structure like this, you are holding it. Where are you holding it? You are holding it in the innermost zone. That is the dark zone. All right. Now, what is happening in the dark zone? Recall that concept. The wax vapors, have they burnt? Are they unburnt or burnt?
They're unburned.
Unburnt. Good. So they will pass via this glass tube. Okay, now it will be passing via the glass tube. Okay. So this, in this glass tube, this vapor that you see over here, that is, they are basically unburnt wax vapors. Now here you have brought a lighted matchstick. Okay, now so as soon as you brought the matchstick near to this, near to the mouth of the glass tube, what happened? The wax vapors would immediately ignite. It will catch fire because here it had a supply of good amount of air. Now here it got the supply of sufficient amount of air, but here while it was in the innermost zone, the supply of air to the wax vapors were difficult. That's why it was not burning. But as soon as you took it from via this glass tube from the other side, it vigorously caught fire. Yeah, Aisha, Ibrahim, and why you're getting it.
Yes, sir.
So what does
Yes,
this
sir.
activity prove? What have you observed here? Aisha, read this paragraph.
Yes, flame is observed. It is because unburned vapors pass through the tube to another end and catches fire.
Okay, so this activity proves that the innermost zone of a candle flame contains unburnt wax vapors, as we proved via an activity that they are combustible as we took it via glass tube. Okay, that was the same activity which we have learned moments ago. Okay, it was the same thing with a different image. Okay, this thing we have learned. Next, we are going to learn about that the luminous zone of the candle flame, it contains unburned particles of carbon also. That is unburned. Okay, now it contains unburned particles of carbon also. Okay, we do have time now. 4 minutes are remaining. Vaiga, please read the given paragraph.
Okay, sir. Let us next perform an activity to show the luminous zone of the candle flame contains unburned particles of carbon. Activity: take a candle and fix it on a table. Light the candle. Now introduce a clear glass slide into the luminous part of the flame by holding it with a pair of tongs. Hold the slide in the same position for about 40 seconds and then remove it. You will observe a circular, a grayish black ring formed on the glass slide in which there is no deposition in the middle of ring. The form Eh, The black deposition is due to the unburned carbon particles in the luminous zone of the flame. The center of the ring does not have any carbon particles because this part was over the dark inner zone, which does not have unburned carbon particles.
Very good. So from this activity, what did we understood? As you have hold this glass plate above the burning flame, and where have you placed it? You have brought it close to the innermost, to the middle zone. Okay, now getting it now. You yourself can do this activity if you happen to have a glass slide at your home. You can do this. Okay, now it's very easy. So basically, via a pair of tongs, we are holding it close to the middle zone. And what is the thing about middle zone here? There are some unburned carbon particles. Some carbon particles are not burnt completely. Like carbon is also present in the wax. No? Carbon particles would also be released due to burning of it. So that is not burnt completely. And the carbon particle would also be released due to the burning of the thread. Now that thread will, due to combustion of that thread, that will also be releasing carbon particles, but that will not be completely burned in the middle zone. How did we get to prove that this middle zone contains carbon particles? As we placed it above this, what we observed that uh, there were deposition of this black patch above the on the glass slide. So these black patches that have developed, these were the unburned carbon particles that were present in the middle zone that have deposited above it. Now, the reason why the center of the zone is not black in color, because this was in contact of the innermost zone, which does not have any unburned carbon particles. You guys understood this? What we have learned in this? Why the center of the ring does not contain any carbon particles? Because it was here the mm, uh, it was over the dark inner zone of the candle flame, no? Which does not have any unburnt carbon particles, but rather they have unburnt wax vapors. You guys getting it?
Yes, sir.
Yes, sir.
Good. From here, we'll be continuing in the next class. If you guys have any other questions, please let me know. By the way, when your schools are opening, when your vacation is going to be over,
August ending.
okay, and others,
I think August 25 or 26.
okay, and what about you, Aisha?
Yes, I think August 20.
Okay. By the way, one more important update I need to take from you guys to tell me what was the last chapter going on in your schools before the vacation. Which was the last chapter going on? Yes.